This video at 4 for doing some longer division with no remainders. I'm going to show you 3 techniques. So first one we have is partial quotients. Partial quotients is when you have like a big bag of candy, and instead of giving everybody one piece at a time, you look in the bag and go, man, I know I can give everybody 10. And you give everybody 10, and then you start again. Sort of like when you were playing War when you were little. Instead of giving the cards one for you, one for me, you'd go, yeah, here's 10 for you, here's 10 for me, oh, 5 for you, 5 for me. So, first thing you'll notice about this one is I'm going to put a line right here to keep my work separate from my subtraction. So, when I do partial quotients, my number one choice is, can I give everybody 100? And no, I can't, because 5 times 100 would be bigger than 70. So then my next choice is I jump down a level and I go to 10. Could you give everybody 10 if there were 5 people? Is 5 times 10 less than 70? Yeah, it's 50. So I subtract the 50 off. When I gave everybody 10, that means I gave away 50 in all. So that was my partial quotient, and now I have 20 left in the bag. Can I give another 10? No, because that's too much. Do you know how many 5s I could give to get to 20? 5, 10, 15, 20. Oh, that looks like 4. 4 times 5 is 20. I subtract, and there's none left. Now all I need to do is add these numbers over here. So 10 plus 4 is 14. 70 divided by 5 equals 14. The nice thing about partial quotients is you don't have to get exact numbers. As you go, you're going to add them up. So somebody may not know the exact number sometime for a certain fact, but they know 10s, and they know 5s, and they know 2s. Trying the same thing over here. 38 divided by 2. Can't do 100, but I know I can do 10. 10 times 2 is 20. Subtract, I'm at 18. How many 2s in 18? Some people may know right now. Some people maybe would count by 2s. I can't do 10 because that would be 20, a little bit too much. But I can do 5 2s because 5 times 2 is 10. I subtract, I'm at 8. Oh, 2, 4, 6, 8. That would be 4 of them. So 4 times 2 is another 8. And now I'm down to 0. Add up 10 plus 5 plus 4. Gives me 19. Let's try a couple more. We made the numbers a little bit bigger. I'm trying to use 5s and 2s the first day to make it easy for you to know the facts as you learn the process. So again, like I've said, my favorite choice is to do 100 at the beginning. Can you do 5 times 100? That's 500. Yeah, I can give away 100 to each person, and now I'm at 145. Can't do another 100 because that would put at 500. Let's go to 10. Can I take 10 5s away? Yeah, because 10 5s would be 50. I subtract, and I'm now at 95. Guess what? I could do the 10 again because I know that's 50. And now I'm at 45. How many 5s in 45? 5, 10, 15, 20, 25, 30, 35, 40, 45. Oh, that would be 9. 9 times 5 is 45. I subtract, there's nothing left. Add these up, 100 plus 10 plus 10 plus 9. I might want to rewrite them neatly so I'm sure what I'm adding. There's a 9, there's a 2. 129. Let's try this one out with the 2s, doing this the same way. Can I give away 100? Yep, because 100 times 2 would be 200. And now I have 336 left. Can you give away another 100 to each person? Yep. So there's another 200 gone, and now I'm at 136. Can I give away another 100? No, because 200 would be way too much. Can you give away? Do you see a number you could multiply this by that would be less than 136? Someone says, hey, I know 2 50-cent pieces is $1, so I could do 2 50s. That would be 100. I subtract, I'm now at 36. Oh, 2 times 10, that's 20. Subtract, I'm at 16. How many 2s in 16? 2, 4, 6, 8, 10, 12, 14, 16. 8 of them. And now when I subtract, I'm finished. 100, 200, 250, 260, 268. Okay, let's try it out the box it up, bring it up. This is a totally different strategy. Okay, it's sort of like standard algorithm with a twist. So here's my box. This is my tens box and my ones box. I'm going to put my tens here. There's my 7. There's my 4. So 74. Dividing by 2. When I go to divide, I just look at this first box, the box of candy. 2 people want the candy. There's 7 pieces. How many can each one get? 2, 4, 6, 8. Each one can get 3. And 3 times 2 gets me to 6. Subtract, I'm at a 1. Bring it up. Normally when you guys are doing standard, you'll see on the next time that we're bringing a number down. We're bringing this 110 up. I put the 110 in front. That makes that be 14. 14 pieces of candy. 2 people want it. 2, 4, 6, 8, 10, 12, 14. Boom, right on that number. 1, 2, 3, 4, 5, 6, 7 of them. 7 times 2 is 14. Subtract, and there should be nothing left today. So 74 divided by 2 equals 37. Let's try it with 85. 8 in my tens, 5 in my ones, dividing by 5. How many 5s in 8? Just one of them. 8 minus 5 is 3. Bring it up. 5s in 35. 5, 10, 15, 20, 25, 30, 35. 1, 2, 3, 4, 5, 6, 7 of them. When I subtract, there's nothing left. See what happens if I make the numbers a little bit bigger? Still going to be the same kind of thing. Except now I'm not going to have just a tens and a ones. I'm also going to have a hundred. So I got 3 in the hundreds, 5 in the tens, 6 in the ones. How many 2s in 3? 2, 4. Oh, that'd just be 1. 1 times 2 is 2. I subtract, I got 1. Bring it up. And now I have 15. 2, 4, 6, 8, 10, 12, 14, 16. So I'm going to go 14. 1, 2, 3, 4, 5, 6, 7. 7 times 2 is 14. Subtract, I got a 1. Bring it up. 16. So 1, 2, 3, 4, 5, 6, 7, 8 of them. 8 times 2 is 16. Subtract, nothing left. My answer is 178. Let's try out one with 5s. There's my 790 divided by 5. 5s and 7. 5, just 1. 1 times 5 is 5. Subtract, I got a 2. Bring it up. 29. 15, 20, 25. Oh, 30's just over, so I want 25. 1, 2, 3, 4, 5 of them. 5 5s for 25. Subtract, and I got a 4. Bring it up. Need to get to 40. 35, 40. There we go. 1, 2, 3, 4, 5, 6, 7, 8. 8 times 5 equals 40. And there's nothing left. So 790 divided by 5 equals 158. Definitely a lot faster than counting by 5s all the way to 790. All right, third and final way. We're going to use the standard algorithm. Okay, in the standard algorithm, I'm going to bring me a box over here first. And just make a rectangular box. Okay. I want this rectangular box to cover up everything except for the first number. Okay, sort of like how I had my box a while ago. So right now I'm just looking at this. How many 2's in 9? Because this part's not there. 2's in 9. 2, 4, 6, 8. By the way, since I normally don't have a rectangle, if I had a big eraser it works. I can also just use my big, ginormous hand and cover it up and it will do the same kind of thing. So 2, 4, 6, 8, 10. I just need to get to 8. That would be 1, 2, 3, 4 of them. 4 times 2. We gave each of the 2 people 4 of them. 4 times 2 equals 8. I put it under the 9. I need to subtract to see how many of them I had left over. 1. 1 has got to be less than the 2, so we're okay. I'm going to get this rectangle out of the way. And now I bring down this 2. And now I have down here 12. So there's 12 left in my bag. I would dividing by 2, so I need to get to a 12. 1, 2, 3, 4, 5, 6. 6 times 2 equals 12. There were 6 2s and 12. When I subtract, I got nothing left. So my answer would be 46. Let's try it with the 5s. Remember, we're going to cover up everything except the first number. How many 5s and 6 without going over? 1. 1 times 5 equals 5. I subtract, I got a 1. Get this out of the way and bring down my other number. Somebody goes, but it's a 0. But it's a 0 that's in the 1's place that changes this 1 in the 10's to 10. How many 5s and 10 without going over? 5, 10, 2. 2 times 5 is 10. Subtract, nothing left. Okay. This way, some people also call this long division because your problem gets written out long ways. Show you one time with a little bit bigger numbers. Get my rectangle going here again. Alright, so this time it's covering up 2 numbers. How many 2's in 3 without going over? Be 1, 2. 1 times 2 equals 2. I subtract, I'm at a 1. Okay, here's where it gets a little tricky for some people. I'm only going to bring down 1 number. So I'm bringing 1 number down. So now I have 14 here. How many 2's in 14? 2, 4, 6, 8, 10, 12, 14. 7 of them. 7 times 2 equals 14. I subtract. I'm at 0. But I'm not really done because I have another number here that we haven't used. So I need to bring this one all the way down here. And now I have 8 pieces left in the bag. How many 2's in 8? 1, 2, 3, 4. And 4 times 2 equals 8. And I subtract, and there's nothing left. And there's nothing behind the orange anymore. Also, that number makes a lot more sense. 300 something divided by 2 cannot just be 17. It's got to be over 100. Let's try the one over here with the 5's. Cover up everything except the first number. How many 5's in 7? We got 1. 1 times 5 equals 5. I subtract, I got a 2. Move this over a little bit. Bring down that next number. 7. How many 5's in 27 without going over? 5, 10, 15, 20, 25, 30. Oh, no, 30 is too much. So there'll be 5 of them. And 5 times 5 is 25. Subtract, I got a 2. Remember, there's another number under this box. Hey, it's a 5. That's nice because we just did this one. How many 5's in 25? Still 5. 5 times 5 is 25. And there's no remainder. So we got box it up, bring it up. We got the standard algorithm, and we got partial quotients. You get to choose which one you like to do.